Okay, so here we're going to look at scientific notation. So in this lesson, we're going to learn about expressing numbers in scientific notation and also in decimal notation. So scientific notation is a number that when it's in scientific form, it looks like a number times 10 to a power. Okay, where A, it's a number between 1 and 10, and n is an integer, which means it's a whole number, and it can be negative or positive. So if we want to think about how wide our universe is, okay, well, it's this many miles, okay? So when numbers get this large, it's easier to write them using scientific notation. So what we're going to do is we're going to write it with the decimal between the 2 and the 1, okay, because we just said that our whole number has to be between 1 and 10. Okay, so the decimal always comes after the first whole number. Okay, and then to figure out how many places they go, well, if I'm right here, I want to think about how many places do I have to go. So times 10 that are all zeros to the 1, 2, 3. Okay, so I just counted 23 spaces, so times 10 to the 23rd. So writing my answer in scientific notation, it's 2.1 times 10 to the 23rd power. Okay? All right, now so going backwards a little bit, well, when do we maybe use negatives? Okay, so I'm going to put my decimal after the first whole number, which would be right here, after the 9. Okay, so my number is 9.02 times 10, okay? So really big numbers are positive. So when I'm going to the right, it's positive. And when I'm going to the left, it's going to be negative. So because I'm going to the left, I know that my exponent is going to be negative. So 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the negative 8, okay? So if you have a really, really tiny number, it's negative, you're going to the left. And if you have a really, really big number, it's positive going to the right. Okay, so I'm actually going to change this one here. So I'd like you to do this problem instead. Okay, so how do I write this in scientific notation? Okay, well, after the first whole number is right here, 2.6. Okay, I'm going to the right, so I know that it's going to be a positive number. So times 10 to the 1, 2, 3, 4, 5, 6, 7. So 2.6 times 10 to the 7. Okay, so if I want to go the opposite way and write this in decimal notation, okay, so here I have 1.8 times 10 to the negative 4, okay, so 1.8. Negative 4 means going to the left 4 spaces. So 1, 2, 3, 4. My decimal is now here. Okay, so I fill in the rest with 0. So my new answer in decimal notation is 0.00018. Okay, it means the same exact thing up here as it does in standard notation. Okay, so here, this is a little 6 right here, times 10 to the 6th. So if I have 4.58 times 10 to the 6th, okay, it's a positive 6, so I know I'm going to the right. 1, 2, 3, 4, 5, 6. Okay, now my decimal's at the end, and I fill everything in with zeros. So my answer now is 458, 0, 0, 0, 0. Okay, and then fill in with commas. Okay, so now let's apply a little bit what we know about using monomials. Okay, so here if I'm dividing, I need to separate. Here, I'm going to separate my numbers with the times 10 to the exponent. Okay, so because I'm dividing, okay, just like whole numbers that we were dividing, it's like the coefficient. Okay, so 4.5 divided by 1.6 is 2.8125. Okay, the second part, what I need to do is, because we're using scientific notation, I want everything to be in the numerator. It doesn't matter if I have a negative. So to get this into the numerator, if it's negative on the bottom, when I bring it up to the top, it becomes positive. Okay? So now what I really have is this. Okay? So I know that when I'm multiplying here, I'm adding the exponents. So I have 2.8125 times 10. Negative 5 plus 2 is negative 3. Okay? So when we're using scientific notation, it doesn't matter if the exponent is negative, but I want everything in the numerator. That's why I brought this up top. Okay, so pause the video for a moment and try this one on your own. Okay, so you should have separated here and here. So 7.2 divided by 1.2 is 6. Okay, this is 10 squared. So if I bring it up to the numerator, it becomes negative. Because it was positive, now it's negative. So I have 6 times 10 to the negative 9, 10 to the negative 2. Okay, so remember when we're adding these, I have 6 times 10 to the negative 11th. Okay, so the other way we use scientific notation is when we're multiplying. Okay, so it's kind of the same idea here except multiplying. So I multiply the whole numbers together, 8.9 times 4, and I get 35.6. Okay, then on the next one, here I have 10 to the 4th and 10 to the negative 3rd. Okay, so multiplying, we add the exponents. So 4 plus negative 3 is just 1. Okay, there is one more step here because this is not in scientific notation. Okay, scientific notation needs to be between, or I'm sorry, after the very first whole number. It needs to be here. Okay, so in this problem from the original, I went back 1. Okay, so that means I need to go back 1 here. So times 10, squared. Okay, so if we look at the first one, let's just go over this again one more time. So 35.6 times 10 to the 1. Okay, what this means is move it times 10, so just move it 1. Okay, but when I change it to scientific notation, I moved it back 1. Okay, so from this point, I'd have to go 2 right to get to the same spot. So that's how I came up with 3.56 times 10 squared. Okay, so try this one on your own. If you're not sure, let's just watch it through. Okay, so this should be again 10 to the 3rd to the negative 7 raised up. So what you should have done is multiply the whole numbers first, 2.8 times 5. And you get 14.28. Okay, here I have 10 to the 3rd and 10 to the negative 7. Okay, so 10 to the negative 4th. Okay, one more step though. This is not yet in scientific notation. Okay, so off to the right, before I even do that, if I put this in decimal form, here negative 4 means go back 4. 1, 2, 3, 4. So this is really what the number looks like in decimal notation, okay? So I need standard notation to be after the first whole number. So I have to think about, well, how is this going to change, okay? If I move it to here, well, how many am I really going back to get to the same? I'm really only going back 1, 2, 3 this time. Okay, to get me to the same answer. You can always double check your work by actually putting it into decimal notation to see.